Now I will start on question 2 for trigonometric functions and identities. Okay, now question 2. Okay, it says prove each of these identities. Okay, so prove. The very first part, it says cos theta equals 1 take tan squared half theta 1 plus tan squared half theta. Okay, so first we can't really do anything with the cos theta because we have like no idea what to do with it, because we can change it to anything, basically anything. So we should start on the right hand side. So right hand side is 1 take tan squared half theta 1 plus tan, draw 2 line, yeah, okay. Tan squared half theta. First, we can make the tans into sine over coses, so becomes sine over cos 1 plus sine So now we have to cancel something out because we can't really do anything because the ones are here. So we'll try to get rid of the ones by taking out things. So we'll try to take out sine squared for each of them. So it becomes sine squared half theta. And that will basically just get 1 over sine squared theta. Or half theta, because when we times sine squared into it, it becomes 1. So this will take 1 over cos squared over 2 theta. And this will be over, we'll do the same thing because we want to cancel out the sine squared, so it have to be sine squared on the outside. I think cos squared will also work, but yeah, sine squared, they'll both work, so might as well just do this because I'm doing it. No, this is still sine squared, but instead of minus, it becomes a plus, and it's still cos. Yeah. Okay, now we can cancel the sine squares out. That just makes it so, and then we should like combine these two because they're additions. So we just get, so this just becomes cos squared take sine squared 1 over 2 theta. And this will be all over sine squared cos, and then cos. Yeah, and this will be all on top of, we'll do the same thing on the bottom, so it's just cos, but plus this time, so it becomes sine to be all on the sine. So for this part will come down, and this whole part will go up, and then one's on top, one's on the bottom, so they'll cancel out. Or we can time the same thing on each side, because these two are the exact same. These two are the exact same, so we can just time them because they're dividing on the same side. So they will definitely cancel out, leaving us with these two in the fraction, like this one in the fraction. So then, but then we know, okay, we'll write that first. So it's cos squared theta takes sine squared half theta over cos squared half theta plus sine squared half theta. Okay, and through the identities, we know that this just equals 0 because they're squares of the same value. So the answer is just no, it just becomes this. Take sine squared. And if we look at our identities, this just equals cos 2u, because cos 2u equals cos squared u minus sine squared u. So this just becomes cos 2 times a half theta becomes cos theta, which equals the initial left hand side. So we've proven it. Okay, now we're gonna do the second part. It was the first part. We didn't. Yes, we did. Well, then the second part is a sine theta equals 2 tan a half. There's no square this time. 1 plus tan squared half theta. Okay, we'll do basically what we did last time by making them into sine and cos first. So, well, we can't do anything with the sine, so we still got to work on the right hand side. 2 tan 1 plus tan squared. So this will just become 2. Will become sine over cos. Oh, half. This all on top of, well, we can just move the 2 to the top, so it's easier to do because it's one fraction then. At the bottom it's still just 1 plus it's not sine squared over cos squared. We do want to get rid of the 1 because it's not inside of the fraction that we made. So we'll continue from the top. So we can just time the cos to the bottom, but let's not do that right now because we haven't simplified it that well yet. So on the bottom it becomes, so we can take out sine like last time because we did sine last time. Might as well just do sine again. Let's do that. So we take sine. We'll take sine squared because then get rid of the. That will not get rid of the fraction, but it'll get rid of the. It'll take out the whole top part. This just becomes 1 over sine squared. That plus 1 over cos. So then we can time the cos to the bottom now. So, and we can also cancel out the sines in this next step. So it will just become 2 on the top. On the bottom, it'll be sine. It'll be this, but we can make this into what we can expand it kind of and then add them together. So it'll be cos plus sine, which is 1, but yeah, we'll do that next. Step by step kind of thing, yeah. And the bottom will still be sine squared cos squared. And then we'll also time the cos to here. So it'll be cos half. Okay. So now we it's together. So okay. So we can just put it into one fraction and move this to the top. So we can basically do 2 because it's like basically one fraction, one big fraction on the bottom. So we can do this, and the bottom would be sine and cos. wait, it'll be plus, yeah, and also this, which is just 1, so we just times 1, so it doesn't really do anything. And because the squares can actually cancel out with the actual cos and sine, so eventually we'll get just 2 sine half squared, not squared anymore actually, half. And this should just equal the sine identity. So yep, sine 2u equals 2 sine u cos u, which is literally what we have. So this just equals sine 2, so which is just sine theta, which equals the left hand side, so it's proven. And there's part B to this question, and that asks us use the result of part A to find the value of tan a half theta given 8 cos theta take sine theta equals 4. Let's do that. So let's write the equation first. So 8 cos theta take sine theta equals 4. So they definitely want us to sub in this sine theta and cos theta, as we do want a tan in the end. So let's do that. I can low power. That's not good. We'll hurry it up a bit. So cos is equal to the, so we, okay, I can just sub it in. So basically this just becomes 8 1 take tan squared a half theta 1 plus tan squared a half theta. Yep, and that takes a sine one, which is 2 tan a half theta over 1 plus tan 1 half and theta. So we see that the bottoms are both the same, so we can put them together. So we'll not write the 4 first, so as we want to simplify it a bit, so that just becomes 8. Yep, and we'll take it straight away because we can combine the bottom ones because they're the same. 1 plus tan. Let's just expand the tan right now. We shouldn't because we want tan at the end. So let's do that. Yeah. Basically the step right now. Let's see. So basically this equals to 4 and this equals to 4. Yeah, okay. I am on the right track. So this equals to 4. So then we can make the equation of 8 minus, we'll just take it because it's the same equation here. Because we have to rearrange and easier to see from like this. So basically we'll move this one over here because it's dividing, we'll time it on the other side. So this just becomes 8 minus 8 tan squared a half theta tan a half theta, and this will equal to 4 plus 4 tan squared a half theta. Oh, that's outside. Yeah, we get it. That's 2 a half. The half theta. Okay. So and then we'll make it into a quadratic. So move these to this side. And this will make it so that the 4 moves to this side. It becomes minus 4. So leave with 4. 8 take 4. And then the 4 tan squared Here's the same tan squared. So then at 8, so it'll be minus 12 tan squared half theta. It'll still be take 2 tan this equals 0. And negative 12 tan. And then we can treat tan a half theta as x right now. So we can do what we do to quadratic formula. Quadratic equations now. It'll be plus 4 equals 0. So I like using the cross method, so I'll try to do that right now. Sometimes it doesn't work, but it should, because it's simple numbers. Normally these work. So let's see, 2, 6, 2, 2, that'd be 4. No, that wouldn't work. This will work, so then that becomes 6, that becomes 8, the difference is 2. Let's see, the bigger one should be negative. Since we do this, this is negative. So this will lead us to negative 2 tan a half theta plus 1 and 6 tan a half theta. It'll be plus 4. So this will result in our tan a half theta in being what makes this 0. So that equals to a half, and what makes this 0. So this have to be negative, and we divide by 4 times by 4. I divide by 6 times by 4. So well, that's just 4 over 6, which is equal to 2 over 3. And make sure it's negative, because we want to remove the 4. So the answer will just be tan a half theta is equal to a half or negative 2 over 3. Yeah, that's the answer. Yep. All right. Bye-bye.